Hey guys, my name is Vikas and I'm from SVC College from C section, and today we're going to talk about network analysis, which is a subtopic of linear algebra. And in this presentation on network analysis through the lens of linear algebra, we'll explore how this powerful mathematical framework unlocks insight into many complex networks. Like linear algebra is used in many various fields like social network and biological fields where it detects how the virus grew from genes to genes, where linear algebra takes place into perspective. So let's dive into it. Unveiling network structure, introduction to network analysis. So what is this networks? Ubiquitous reality. Networks are everywhere, from social connections to transportation systems, from biological interactions to internet. They represent relationship and connections between entities. So networks are everywhere, basically it's telling. And the power of linear algebra. Linear algebra provides a robust foundation for analyzing network structures, enabling us to quantify relationships between uh, discovers patterns and gain valuable insights. So, the power of algebra, linear algebra, where it shows the current patterns and relationships and gain valuable insights. So, let's move on to the next slide. Representing networks, graph, and matrices. Graph representation. So graphs are visual representation of networks with nodes representing entities and edges representing connections between them. And adjacent matrix. Matrix are encoded with network relationships with entities representing the presence or absence of connection between nodes. And Levelation matrix. Another key structure which is used to analyze network dynamics. So let's move on to the next slide. So network dynamics, Kirchhoff law and linear equations. So Kirchhoff's law, the fundamental law govern current flow, voltage drops in electrical circuits, forming the basis of analyzing network dynamics. So Kirchhoff's current law, where sum of current is equal to the sum of leaving current, that is used in this. And linear equations, Kirchhoff law translates into system of linear equations, allowing us to solve for unknown current and voltage in network. So let's move on to this next slide. Exploring network influence, centrality measures, and eigenvectors. Degree centrality count the number of connections node has, indicating its direct influence. And eigenvector centrality measures a node influence based on its connections to other influential nodes, revealing indirect influence. So in degree centrality, it counts the number of connections of nodes which it has, indicating direct influence. And eigenvector centrality measures a node influence based on connections to other influential node, revealing indirect influence. So it has eigenvector centrality has an indirect influence to the nodes, and degree centrality has a direct influence to the nodes. And betweenness centrality identifies nodes that lie on shortest path between other nodes, indicating their importance as connectors. And discovering community structure, clustering, and community detection. Community detection identify groups of nodes that are densely connected within the group and spatially connected to other groups. And clustering algorithms. Techniques like spectral clustering leverage eigenvector information to identify communities within the network. Applications. Understanding community structure reveals hidden patterns and facilities targeted interventions. So, in community detection, it identifies nodes which are densely connected within the group and spatially connected to the other group, where it is also connected within the group and it is connected to another group which is outside. So, clustering algorithms, technique like spectral culture, leveraging eigenvectors information to identify communities within networks. And applications, understanding community and how this network analysis is applied in this. And learning from networks, graph neural networks and machine learning. So graph neural networks, what is this graph neural networks? Deep learning models designed to process graph data, enabling predictions and insights from complex network structures. So it enables deep learning mode designed to process graph data, enabling predictions to be done. And applications used in diverse applications, including drug discovery, fraud detection, and recommender system. And future of network analysis. Advanced in graph neural networks promise to unlock even deeper insights and drive innovation application. Network analysis in action, real world application. So where is this network analysis basically used in the real world? It is used in traffic optimization. Network analysis optimize traffic flow, reduces congestion, and improves transportation. Because of network analysis, we are using software called maps, which is very useful for traffic optimization, where you can easily get to know how it is the flow of traffic. Is it jam or is it free to go? Stuff like that. And social influence analysis. Network analysis identified influential users, predict viral content, and understand the spread of information. So, network analysis is basically used in social influence analysis also, where influencers are predicting what the viral content are and which are not by the connection of nodes, like stuff like that, where you can connect. Drug discovery. Network analysis identifies key protein pathways of drug development leading to new therapies. So, network analysis is basically used in um, drug discovery or biological way, where you can get to know what the gene to gene stuff like that by using network analysis, where it is used in biological way, where uh, it is used to create like and identify where the virus has come, and from what is the destination of what is the location of the virus, and how did it build from this to this, with gene data, with node to node detection, like stuff like using network analysis. So, looking ahead, conclusion and future direction. So, what is the conclusion of network analysis and future directions? Network analysis is a rapidly evolving field with immersive potential as our understanding of complex networks deepens, drive by linear algebra and machine learning. We can expect breakthroughs across numerous domains, shaping our world for the better way. So yeah, network analysis is ahead in the future, and it's gonna be a big thing, and it is already a big thing, but it's gonna progress. So yeah, guys, this is my presentation. Thank you for watching.